Okay, I think it was my cue to begin. Hi, everyone. Welcome. Thank you for coming to this session. My name is Alina. This is my first time at CERN, and I'm super excited to be here. Yesterday, we had a tour of Atlas. That was amazing. We are now all in love with the venue and the conference. And I work at Oracle on GraalVM, and this is something that I'm here to talk with you about today. Normally, I have this session lasting like 50 minutes, maybe 1 hour. So I guess I will need to do less of chit-chatting today, and that's a problem because I like to chit-chat. But let's see if I can squeeze it into 45 minutes. So I remember in the morning, Stefan and Alfonso asked the same thing in their session, but can you raise your hands if you have tried building something with GraalVM already? Okay, I would say like majority of the room. And have you tried building something with native image specifically? Okay, cool. I'm happy to see my colleagues raising hands. So at least they are definitely using GraalVM, but there are more people in the room too. Okay, a quick intro. So this is my first time here. So my name is Alina. I actually live here in Switzerland in Zurich. And I'm a developer advocate for GraalVM at Oracle, and more specifically at Oracle Labs, which is this very cool R&D unit at Oracle. If you maybe remember Sun Microsystems, this used to be Sun Labs. And ever since Oracle acquired Sun, it became Oracle Labs. And we are still doing a lot of research at Oracle Labs. And GraalVM is one of our research projects turned products. And I love open source and communities. That's why I like coming to places like this conference. And I love both programming and natural languages. And if you have any follow-up question, you want to ask for slides, demos, maybe you have tried GraalVM, you want to follow up something, you can find me on any kinds of social media just by my name. Okay, GraalVM. So if you have tried GraalVM or if you have heard about it, it's kind of confusing sometimes because there are so many things that GraalVM can do. There are roughly 3 big parts of the project. But in the end, it's a JDK, just like any other JDK of your choice. And what makes it particularly stand out is that it can also ahead of time compile your Java applications into native executables. And this is something that only GraalVM can do. So basically what we are doing, we have our base JDK, and we just add things on top of it, such as this ahead-of-time compilation. And anything any other JDK can do, GraalVM can do just the same or better. And additionally, it can also ahead-of-time compile your Java applications. So with GraalVM, you do get this choice. You can either do normal Java in a just-in-time compilation mode, or you can do this ahead-of-time native image compilation. You don't need to go one way or another. With GraalVM, you do get to have this choice. Do I want to do JIT, or do I want to go with native image? And we will talk when is the good case to use which. And this slide, for me, is also the answer to this question that I get at conferences sometimes. So people are trying to, kind of catch me and ask me this tricky question, when should I not use GraalVM? Like, what is a bad use case? And my answer is always use GraalVM, but decide for yourself which part is best for you. So the TLDR is if you want just your normal Java execution mode just in time, but you want a better compiler, a faster compiler, go with GraalVM as a JDK. Just swap your JDK installation for GraalVM, and you get a better compiler out of the box. The rest stays the same, so the migration is roughly 5 minutes, I don't know. Or if you want to have faster startups, lower memory usage, more compact packaging, you can go all in with this ahead-of-time native image compilation, and then you get very different benefits, such as those that I mentioned. But long story short, with GraalVM, you can do either or. It's never just one way. You can do what you can do with any other normal JDK. And I like showing this slide because for some people, GraalVM might be new, but actually has been around for a while. And the reason why I like showing this is because, A, I think this is a beautiful slide, so I'm happy what we did there as a team in terms of design. But also it shows all those important milestones in our history. And if you want to look up, you can maybe take a photo. I can send you the slides, but I want to highlight just a few things that are super important to me, at least. So back in 2011, Thomas Yurtinger, our current project lead and VP, joined Oracle and started this project at Labs that now became GraalVM. And then a few other of my favorites on this slide is that in 2019, we went with our first production grade and also commercially supported builds. So we were working on GraalVM as a research project for over a decade. And then in 2019, we were confident enough that it's stable to go public with like this commercially supported version. And what's funny, this is in 2019, but back in 2018, before we even had those first commercially available builds, the Micronaut team saw the potential in GraalVM, and they went all in and started using and even recommending GraalVM as a deployment platform before we even went with our GA builds. So that was very nice of them. And then another milestone that is very dear to my heart is then in 2020, Alibaba started using GraalVM and specifically native image in production. And the reason why I like this story so much is because native image, this ahead of time compilation, it might look, to some people very revolutionary and scary and a very non-traditional way of doing Java. And I can see definitely how it can be scary. But you can see that Alibaba has been using GraalVM and native image since then, and they were very happy. And you can imagine Alibaba, what kind of scale and what kind of load they have in their production environment. And they said that they have been using since then, and they've been quite happy. OK, and just to speed this up, a few more things. So in 2022, also Spring Boot introduced support for native image out of the box, and we had many more accomplishments since then. So very quickly about this ahead of time native image compilation and how it works. So how is it even possible to take something as dynamic as a Java application and compile it ahead of time? Because as we all know, there are many things that Java, and especially frameworks, do at runtime when you first start your application. And for us, the runtime technically hasn't happened yet. So how is it possible to compile something as dynamic as a Java application ahead of time? So when you run our native image command and you give it your application, and as input we take bytecode, so it has to be a jar or class files, what will happen is we will look at your application starting from its main entry point, and we will try to find everything reachable, so all the things that your application is actually using as opposed to your complete project, and then only include those things that are actively used into that produce native executable. So analysis is one part of the story and ahead of time compilation, but there is another part of the story, and that is as we are analyzing your application, we are also looking at your heap, and we are trying to determine what are the objects that are safe to initialize at build time, so that you can start with this pre-populated heap, pre-initialized, and save some additional effort and time of not doing this at runtime. So analysis, ahead of time compilation, and heap snapshotting, and as an outcome of this, what you get is a native executable, a native version of your application that is pretty much fully self-contained and fully capable of working without a JVM. You can just deploy it on a machine that doesn't have a JVM on it, and it will be fully functional on its own. One more note here, you can see the platform icons. So this native executable will be platform-specific. This is something we will get to later on as well. Now, I don't like talking a lot, or like I do, but I also like showing demos. So let's see if we can see this in action. Let's see, and I need to thank CERN for the amazing internet, because I will be demoing thing on an isolated instance to not interfere with my local machine, and the Wi-Fi is amazing, so thank you, CERN. To start, let's check my Java version, and I'm here on Oracle GraalVM for JDK 24. Now, if you are paying close attention to Java versions, you might point out that this is not a released Java version. The released is 23, but 24 is coming up in like 8 weeks from now, and you can already get early access builds and help us test it. You can even already get 25 builds, because we even built those already, but the upcoming release is GraalVM for JDK 24. And let's run this application, and let's see what it does. And first, we will run it, and we will look at the code in a bit. But you can already kind of see it's spoiler that this is a Spring Boot application. So let's run it. And it runs, and it takes a while to start, despite this being a fairly beefy, dedicated instance. But it starts in something like 2.4 seconds, and then it runs on 8080. So let's go and see what it does. So it's a dictionary application, as was suggested in the name. And here are my translation that my application retrieves for me. Now, I want to apologize that this is not in French, and this is not in Swiss French. I wouldn't dare. My Swiss French is even worse than my Swiss German. But hopefully, the point, like you get across that this is a dictionary application, and we are able to retrieve our translation on this endpoint. So that's an application. It started, it's working, but it started for me in 2.4 seconds, which is not great. So let's see if we can improve it. For that, we will compile it to native with native image, and we will do this maven p native compile. And as it compiles, we can super quickly, because it will not take that long, take a look at the actual application. So this is my demo app. This is the controller where we have our endpoint, we have our service, and we have our repository, and the actual data is stored in H2 with our translations. And in terms of project structure, it's a Spring Boot project. It has a number of dependencies for data, for web, and for me, the interesting part is this native Maven plugin, which you can tell is coming from ourselves, from the GraalVM team. So this is a unified kind of interface and facade to native image. So many frameworks include this by default as a way to interact with native image. And I do like this way a lot because this is framework agnostic and you can do anything from here. For example, I have my build configured to be slightly faster for development purposes. So I'm saying this is not for production yet. I'm still developing my app. I don't care about speed at runtime. Just give me back my build faster. So this is the project, and if you look back at our build, if you have ever built a native image application, and especially if you are a rather impatient person, you would afterwards come to me and say something like, Alina, oh my God, this is taking so long. Why does it have to be so long? I don't have those kind of patience. Like, do something about those native image builds. But check this out. So my application is fairly trivial. It's maybe 5 classes. In the meantime, native image, as it was analyzing our application and building this kind of universe and understanding of my project, what it detected is despite my app being trivial on the surface, it still includes 33K reachable types, over 51K reachable fields, and then 187K reachable methods. And by reachable means actually this was reached and deemed important in the analysis phase. So for example, methods, this is 187K out of almost 300 total. So while my own code that I wrote is fairly trivial for demo purposes, under the hood, I have my framework, I have my dependencies, I have my JDK. So Java projects make us productive and make our applications fast, but there is quite a bit of complexity going on under the hood. And this is why native image needs some time to figure out all of that as it builds your application. But the trade-off that we are offering you is you do this work once as you are building your application. And then when you start it, it starts much faster every single time. You kind of are shifting all that overhead work from runtime to build time. Let's see if that's truly the case. So we have our application compiled, and we have, unfortunately, some additional files courtesy of IWT, but let's run it. So target dictionary. So it was starting in 2.4 seconds previously. Now it's just 148 milliseconds. And if we go back to our endpoint, it's doing the same thing. Only now this is no longer Java or no longer your regular Java. This is now a native application. So if I check what's inside my target folder, this is my newly compiled application. This one is fairly larger, but nevertheless, this is a complete native version of my app, and it starts much faster, as you can tell. Now, this is how you take your Java application and compile it to native image. And one of the benefits of using native image and why would you do it will be fast startup, something that we have seen just now in the demo, where your application can start in milliseconds as opposed to seconds, because unlike the JVM, we don't need to load classes, look at them, profile, analyze, compile. We are doing that when you are building, and then you can start much faster. But you can tell me something. Let's say I have a longer running application and I deploy it and then it runs, I don't know, for hours, days, weeks. So startup is irrelevant for me. In that case, is there something native image can still do for me? And the answer is yes. So in addition to startup, we are also using fewer resources at runtime compared to a normal JDK, because we don't need to bring all that infrastructure and we don't need to do a lot of that overhead work of loading your classes, compiling, profiling, etc. at runtime. Again, we did all of that at build time. So it's kind of hard to give generic numbers, but on average, when it comes to memory, and that's one of the most kind of pricey cloud resources, memory-wise, you can get maybe 3x, 5x less memory usage with native image as opposed to running your application on the JVM. Now, another interesting benefit of native image is predictable performance. So if you were to imagine the performance profile of your application running on the JVM, there can be quite a bit of fluctuations because new things might be loaded, GC might kick in. There is way more dynamism in that regard on the JVM, while on native image, everything is compiled and optimized ahead of time. So if you were to imagine this performance curve of native image, it will be very high from the very beginning, and also it will be very stable over time. And if you have users and customers for whom this is very important, that this performance is stable over time and doesn't change dramatically because they want to meet some SLAs. Now, if we get to it, we will talk a bit about security, but there are additional benefits in native image and its own programming model when it comes to security as opposed to the JVM. So all the code is ahead of time compiled, nothing new can be loaded, nothing new can happen at runtime as opposed to running on the JVM. And if you want to have smaller executables or smaller container images, this is also something we can do because we don't need to bring the whole JVM when you're running your application. Lastly, I did mention a few frameworks, but if you are starting your application right now in 2025, there is really no reason for you not to use GraalVM and native image because all those frameworks, all those cloud vendors offer support and even additional features if you are using GraalVM on their platform. Now, talking about frameworks and libraries, I want to talk about how you can use libraries in native image. And there are things to know and why things are not so easy with native image. I'm wondering if some of you have tried building something with native image and maybe it didn't work out because of a library, so you got some error at a build time or runtime. Yeah, I do see some hands. So why is this happening? And I want to illustrate this on the point of a Spring Boot application, because there they needed to develop an entire project to make things work and transform towards native image. So where those challenges might come from, and why, for example, some people say that reflection is challenging for GraalVM, is because we discussed that native image builds the application ahead of time. The runtime hasn't happened yet. So everything there is to know about your application needs to be known at build time. So if you load something new at runtime, or if you resolve something at runtime, you need to instruct native image about it ahead of time when you are building your application, because nothing new can happen at runtime. And this means that things like reflection, they do work in native image, but more complicated cases, you would need to provide instructions and hints to native image to help native image understand as it builds your application what exactly will be happening in terms of reflection. And this doesn't mean that necessarily you need to write that code, but it does mean that your library or framework, if it does some reflection, it needs to instruct native image through the configuration files that this and that, let's say, will be reflectively accessed at runtime. Long story short, native image can do pretty much anything for you as long as you tell it at build time what needs to happen. And to illustrate this point, as I mentioned, we will use Spring Boot as an example. So the way Spring normally works, or the way it used to work in the pre-GraalVM days, is when you start a Spring application, upon startup, Spring looks at your application and pulls all the pieces together, your class files, your configuration, to build this understanding and kind of your project structure at runtime to glue all the pieces together and see how they fit together. And what's interesting, as we discussed, native image does the same thing. So it loads your project, it looks at your config, and it's trying to see what needs to go where and build this universe of your project. Only there is a kind of conflict here, because normally Spring would want to do these things at runtime, and native image wants to do those things at build time to save you time and trouble when you're actually running your application. So to bridge this gap, they developed this project called Spring IoT. And this is a project, and now also a step when you're building your Spring projects with native image. And the way this works, it will transform your Spring project into a format that native image can better understand. And among other things, it will generate a bunch of things for you to assist that native image compilation. So one thing it will generate for you is actual Java source files. So for example, if you have configuration in other formats, it will transform that config into more functional style config that is easier for native image to resolve. Next, it will generate even bytecode for things like dynamic proxies, and then it will generate those hints files that are used for things like reflection, serialization, GNI proxies to instruct native image about those features as it builds your application. Now, this might seem a bit complicated, but if you want to build your project with GraalVM, and if you want to see what are the libraries out there that you can use, as the easiest kind of assessment step, I would recommend that you go to our page on our website. It's called Ready for GraalVM Native Image. And there we have a very, very long list of frameworks and libraries that integrate with native image and continuously test. And this is community reported and community maintained. But this list is a good hint that if your libraries and dependencies are on this list, then they definitely work. If they are not here, they might work, but you can give it a try and build the application. But if they are here, they're definitely known to work. And this list goes longer and longer by every day, basically. Now, this slide will look a bit scary. I will try to cover it fast. I'm not sure I will succeed, but let's say you wanted to use a library with native image, and going from the best case scenario to a kind of slightly less fortunate scenario. If your library is not yet compatible with native image, what are the recommended steps? And this will look a bit scary, but I do want to cover this. If you want to build something real world with native image, you will need your libraries. So how can libraries work with native image and all those limitations that things like reflection need to be resolved at build time? And each bullet point here is a complete solution. So this is going from the best case scenario to a scenario where you need to do a bit more work. Now, the best case is if a library is native image friendly out of the box. And we see more and more of this lately when people publish something new and they build it aware of native image. So this is the best case. You pull it, you build it, it all just works. Now, there were many libraries before GraalVM and native image came to be, and obviously they were not built that way. So what to do if you are a library maintainer and you want to make it friendly towards native image so that your user can build your application with your library with GraalVM and native image? The dictionary application that I was showing before, it was using H2. And I like this example because in the past, I had a demo where I would try to use H2, and then it would break because it could not figure out how to work with reflection. But now this is not the case anymore, because here we are looking at the actual H2 source code. And among other things, they are shipping this file called reflect.config.json. And this instructs native image to please make those things available as you're building the app so that H2 can be compatible with native image out of the box. And this just comes within H2 itself. You don't even notice it. You just pull it as a dependency, and then those things are resolved for you automatically. So this is another fortunate scenario. And those three are kind of good steps that I hope most applications will be resolved through those first steps. So either the library is friendly out of the box, or maybe it includes config for native image within the library itself. But also realize that not all the libraries have done this work already. Some are still working on it, or some are still coming to that place. And what to do with the libraries that do not have config for native image, but also they do not work without this config. So you would think it would be great if there existed something kind of like Maven Central, where let's say if I can come up with a config for my use case, I can just contribute it to this centralized repository so that other users can just reuse it, and people don't need to come up with config for the same libraries, each by their own. Now, we saw the same thing, and together with the community, we created this space on GitHub called GraalVM Metadata Repository. And here you can see, again, a long list of libraries and projects, and all of those folders contain configuration to use each of those projects with native image. So for those, again, things will just work. And the best part is, remember I showed you our Maven plugin coming from the GraalVM team, and we have the same for Gradle. So those two will pull this configuration for you. If you're building a project and you have other plugins, they will just resolve config. You don't even need to know that there is some black magic happening under the hood. And I would say if you're starting a new project right now in 2025, I hope you will never go beyond those three first bullet points. But let's say maybe you want to use some library that is your own internal. It's not anywhere in the public, and also doesn't contain config for native image. And you don't have config for it either because it's your internal thing. No one else contributes to it. What you can do in this case? If you are on a framework that is friendly towards native image, has an integration, so that will be Micronauts, Spring Boot, Quarkus, Halidon, most of them offer some kind of support of generating hints, those configuration files for native image programmatically. So to look again on an example of a different, this time, Spring application, I have a Spring app here. And let's say we want to do a reflection. And we are doing it here in a maybe less obvious and less elegant way. So what we are trying to accomplish is we want to get this field called message from the message class, so the one over here. But we are doing it in a slightly more weird way to try and confuse native image, because if this was a bit more sane call, native image would just figure it out of the box. So for the demo purposes, we are trying to confuse it so it breaks just for demo. But there is a way to resolve this. So the way to figure this out will be, because I'm on a version of a framework that supports native image, what I can do here in this case, I can use an annotation from Spring called register reflection for binding, and then I will pass that place where that reflection call needs to occur. So for me, that will be message class. And this way, Spring will go and look at that message class, and it will generate hints for me so that that field is accessible for me. Now, this is a bit of manual work, but still, I would say this is not too bad, because I'm still in my kind of programmatic way of resolving things. This is one API. Another useful API that I like is this one, where let's say we want to load this resource at runtime. And for that, again, we would need hints in this case, because this is also some custom code that I wrote. So instead, instead, we are using this runtime hints registrar API. And we are just saying hints resources. I want to register this resource, so please make it available for me in the native image mode. And the reason I like this API is because it's more flexible. So here we are doing hints for resources, but in a similar fashion, I can do hints GNI, and do things for GNI or serialization or proxies or anything else. So this is a more flexible API to help me resolve all those things for native image. So this is something you can get from a framework if you're on a version of a framework that supports native image, and that's pretty much all the latest versions of Java frameworks. Now, just to finish this slide, so we were talking about if you are in this kind of slightly less fortunate scenario where you need to produce those hints yourself. If you are also on an older version of framework, or maybe you have some internal framework, and there is no support from the framework for you to make applications work with native image, what you can do is you can use a tracing agent within the native image itself, and you can run your application on the JVM, and it will look at your app, and it will collect and produce those config files for you. And lastly, you can also write those manually for yourself in the format of JSON files. So if you have one teeny tiny reflection call, you can just tell native image, hey, it will appear here and there, please make it available, and it will do so. So this was slightly more scary, maybe, but if you will ever use any libraries with native image, I hope that this slide will be helpful for you. That's one. And I also hope that you will never go beyond those 3 first points where things are resolved for you automatically. Now, if you want to test your application, talking about good development practices, there is also support for JUnit, and it's also quite fine-grained, so you can enable or disable things specifically in the native image mode, so you can have different setups and different test cases specifically for native image. Now, performance. I want to talk about performance because I work on a compiler team, and for us, performance is one of our main priorities. We used to say that if you have GraalVM and things run slower on GraalVM than on any other JDK, report back to us because this is a bug. Nothing can run slower on GraalVM as any other JDK. So we take performance very seriously, and for that, I want to show you another demo. And we will take our old friend, this dictionary application, for a spin. And to speed things up, this will be our benchmarking setup. Let me just close other things. So we will start our application on the JVM, and we will use C2, so like your normal JDK compiler. You can think of this setup as your OpenJDK setup. And we will start our application. We will attach the tool called PS Record. So we also have nice charts when we finish our benchmark. And then, OK, sorry, we are looking in the wrong folder, but it does have a similar setup. This one, yes, because I remember that we should send 500,000 requests. So we will start our application, we will use PS Record, and then we will send 500,000 requests to our application, and we will compare the performance on the JVM versus GraalVM native image. Now, by no means, this is not a scientific benchmarking setup. Scientific benchmarking setup will take multiple hours at least. But for the sake of conference talk, let's pretend that this is a good enough quick benchmarking setup. So let's run this, and this will run on an OpenJDK-ish kind of setup, sending 500,000 requests to our application. Let's see. And the actual kind of load generating tool that we're using here, and also benchmarking tool, is Hey. OK, this is done. The way to look at this, we could be looking at latency numbers. They kind of look OK to me. But I prefer looking at peak throughput numbers because, for me, they are most telling. So the same application that we were looking at with translation, on the JVM, we have 56K requests per second. So do you think this is fast or not? You can just shout, fast, not? Fast. Well, I think it's kind of fast, but also I feel like it's kind of hard to make conclusions unless we have something to compare it with, right? So let's run the exact same application versus native image. We will have the exact same benchmarking setup, only we will be sending those 500,000 requests to a native version of the app, and then we can compare. So who thinks this native version will be faster than the JVM version? I'm glad that you have faith in me. Normally at Java conferences, you would hear like, oh, native code ahead of time compiled can never be faster than Java. What are you talking about? Like, let's see. So the Java version was at 56K requests per second, and then the native one is at 46. So what, 10-ish% slower? Now here I could have said things like, the JVM is the beast. It's very hard to beat the JVM at its own game. We need to give proper credit. But I do think that we can do better. So let me get one more tab, and we can run one more experiment here. And I have something called native optimize. So that is a different version of the same app with a few more additional optimizations. Now, you can kind of deduct from the name, but also from the fact that I'm working on the project, that probably this will be faster. But let's see. OK, this one is also done. So this was 56K. This was 46K. And this is now 60. Now, again, all the legal disclaimers that this is not proper benchmarking and so on. You should experiment on your own app. But I hope it gets the point across that you can have the performance comparable with the JVM, and definitely faster than the out-of-the-box native image version if you apply a few specific optimizations. Now, we will talk about which optimizations in a second. But before we switch back to the slides, I want to show you one more thing about this benchmark. So we were measuring things as we were running our application, but also we were measuring in the background the performance, or rather resource consumption profile of each of the versions of the app. And now we will analyze those two. Remember how I said that native image is good for startup, good for peak throughput, but also it's very good to minimize resources usage on your machine. And this is indeed something that we are looking for. So we measured also this JIT, native image, and native optimized as we were running the benchmark. We used a tool called PS Record for this. And the way to read this is the vertical red lines, that is CPU usage, and the horizontal blue line, that is memory usage of our application. And the application ran with the exact same settings in all three benchmarking scenarios. But as you can see, the resources consumption profiles are very different. One more thing that I should have said in the beginning, we are starting our application, and we are just waiting 5 seconds to give the JVM a chance to properly start. So you can see that native image is kind of started, and then it's ready and just sitting, because we have the exact same setup, so we can compare side by side. So for the first 5 seconds, we are waiting, and then the actual benchmark kicks in. Now, a few observations that I have here. So you can see the JVM is quite busy in the beginning. So it's called start, so it needs to load the JVM, it needs to start loading your application, understand what's going on, interpret, compile, all of that. Native image is not so busy in the beginning. It kind of starts and does something, but other than that, it's ready to go. And then when the actual load hits, the JVM basically goes through the roof with CPU usage when that first load arrives. It kind of stabilizes afterwards, but it goes quite high. And even though X and Max settings are the same for each 3 our benchmarking cases, the JVM version kind of goes overboard because it needs more memory to address that increased load, while native image out of the box, it's quite moderate on memory, I would say, and we could tune it even further down. And thus, this final optimized version, it does use more memory than native image out of the box, but that is because this one has a different GC, and that different GC gives better peak throughput, but at the cost of slightly increased memory than out of the box. Still better than the JVM, though. And I like showing this slide because I think, not slide demo, because I think this is important that in addition to fast startup, which everyone more or less agrees is a big benefit of native image, you can also significantly reduce resources usage. So either pay less in the cloud or use less of your own infra, and also do the right thing and not burn resources where you don't necessarily need to burn them. Now, what was the magic in this final setup? What made the native image application so fast? So if you want to have the same result, and we have this big mission on our team, we are saying that we want to have AOT at the speed of JIT, so that your natively compiled applications can have the same peak throughput as the JVM. So how do you accomplish this? There are a few solutions here. The first thing that I want to mention is profile-guided optimizations. And the way people tell us that native image will now be as fast as the JVM is because people know that the JVM profiles your application. So as it runs, the JVM looks at your application, it sees what is hot, and based on what is hot, it makes a decision which part makes sense to optimize because it will have the most impact on your final peak throughput. And they're saying, oh, but with AOT, you don't have the profiles, so you can now be as fast. Technically, you do not have profiles, but you can still have them. So with PGO, what you can do is you can build an instrumented version of your application, run it, apply relevant workloads, so we can see what is actually happening in your application and which parts and methods and loops are hot. And then we can collect those profiles and then feed them back into native image, so it can build an application that is aware of what will happen at runtime. So we are still building at the build time, but we kind of have a runtime awareness of what will happen in the future, and we can have kind of this similar level of profiling as the JVM has, and in a way it's better, and in a way it's even like it is better in a way because we have a more complete vision of your application. So unlike the JVM, nothing unknown can happen to a native image application. We see the full picture at build time. What to do though, because this requires an additional step, right? So you're building an instrumented version, you're collecting profiles, and then you have one more build step where you are using those profiles. But maybe you cannot have this two-step process, or maybe you don't care about peak throughput that much. You just want like good enough performance. And you're saying, okay, I don't have profiles, but seems like guessing those profiles seems like a reasonable task for an ML model. So why not use ML? Because everyone is using ML, right? So we had the same idea, and indeed we are shipping a teeny tiny ML model with a native image, specifically the Oracle GraalVM version of native image. And that teeny tiny model will look at your application and will try to infer profiles and see where it makes sense to invest those compilation efforts. So if you don't want to do this two-step build process, you can just build with ML-enabled PGO, and you will get something like 6–8% performance improvement out of the box in terms of peak throughput, comparing to not having any profiles in place. Now, when I was talking about memory usage and a different GC, so the GC that I used in the last case was G1, and there could be different GC strategies, but as a rule of thumb, if you specifically want good peak throughput, we recommend that you try out G1 GC, and for most native image applications, this will give you the best peak throughput. Now, the last point here, and like a smaller one, but still I recommend that you use it. If you know that you are building your application on the same machine where you will be deploying it, you can pass this flag called mark native, and this instructs native image to specialize the native executable to the specific hardware features of this machine. So it will be platform specific already, but this will make it very specific to this specific hardware features and squeeze those last few % of performance improvement. So if you want to have very fast native image applications, this is your recipe to do so. And I mentioned memory usage, but lately we see this new trend where people reach out to native image to see if it can be a more kind of energy efficient way of running applications. And I saw yesterday some data about how much energy CERN consumes every year, so maybe this can be something interesting for you guys as well. So we have more and more users reaching out to us asking, okay, seems like native image might be a greener way of running Java applications, and indeed it is. So I keep repeating this throughout the talk, but basically we do less work at runtime than the JVM does. This means that we need less time, less memory, but also less energy as you're running your application. And here we are running our benchmarking application in different scenarios with just one request or with solid load over the time. And even under a constant high load, you can see that native image, so the orange version of the application, is about, I would say, 1/3 lower energy consumption than the JVM version. So if you want to save the planet, the turtles, do the right thing, native image can also be your way of accomplishing that. Now, about best practices. So if you want to build applications with native image, there are multiple ways how you can package them. But also, I mentioned that you can have very small packaging size for native image applications. And indeed, here we are looking at the last scenario of a container image of the JDK simple web server, so an actual web server. And the image size in that case is just 18 megabytes, and that everything that you need to have in that image to be run on your JDK web server, as opposed to packaging the JVM and everything that you need to have to go with it. You can also experiment with what works best for you. You can fully statically link your application, or you can just link a number of things depending on what you want to accomplish. But if you want to have the possible smallest containers, native image will be the way to go for you. And I did mention that native image produces platform-specific native executables. So let's say out of the box, I cannot build on my Mac machine for Linux. This is not supported because we need some platform-specific JDK classes. There are multiple ways around this. You can do CI/CD. I'm a big fan of GitHub Actions. I feel like they should start paying me at some point for saying this, but I do like them. It's very easy to set up. And this way, you can have builds for whatever platforms you need. So either containers or CI/CD will be your solution for cross-platform kind of builds with native image. And build packs would be one good way to do so, to have those container builds. Now, if you want to move your existing application to native image, those will be my recommendations. As a first step, add our Maven and Gradle plugin coming from our native build tools, and just try building your project and see if it works. Specifically for new projects, things will just work out of the box. Now, for building and deploying, we normally recommend that you build and test and develop your application on the JVM, and then you compile to native either in your CI/CD or once a day, or when you introduce major changes like a new dependency, or when you attach in things like reflection. But you don't need to recompile all the time as you are still building your application. We recommend that you do it on the JVM and then compile to native closer to deployment. And if you want to optimize for performance, those are the things that I mentioned before. So if you want to take one photo from this presentation, probably this will be the slide to do it. OK, good. Now, one more demo. I'm not sure how I'm doing. OK, probably we still have time. Now, I also promised to show monitoring. Let's see if I can do it. So I want to show you a way of having monitoring and observability with native image applications. So let me close all of this. OK, observability. Which one? This one. Now, this will be a demo that I adopted from the nice Micrometer people, and it's native image friendly. This one is new to me, and I'm slightly anxious about this whole observability stack because I borrowed their setup. But let's see if I can get this up. Compose up D. OK, this is starting to come up. In the meantime, we can get another tab. So we will have a setup where we have our server application and a client application that are talking to each other. And then we will see if we can trace and see the connection between the two. So I already have my server application compiled here. And as you can see, it's green. So this is in my terminal an executable. This is already a native image app. So let's start the server. And let's get one more tab for our client. So client, target client. And we already see Exchange. So the client application is sending requests to the server, and they're communicating and responding. And if all this worked out, we will be able to see the connections between them. So let me go and get our dashboard. This will be 3000. And this one. So at least we already see the latency numbers, so we can see how our services communicate and what are the latency numbers. Now, this takes a while to propagate, so I can see my logs and traces. Let's see. It can take anywhere around 1 minute. OK, come on. I know that it will come up. It will just might take a while. Come on. Yes, done. OK, the complicated part is behind. So now we can also trace our entire request. Here we can see that we had indeed our client application going to the server and then fetching that user by ID and getting the name. And we can see the times per each operation, and also how those services come together. And this whole setup, the observability stack aside, is all running as native applications, like two GraalVM compiled applications talking to each other. And we can see the connections between them, latency times, traces, and also how those microservices come together. So this is pretty cool. And I see that I have 30 seconds left. So let me just switch to one of the last slides. So if you want to get started, this is the place where you can come. This is our main website with docs, guides, and everything. You can pull our container images, or if you are using SDK Man, as you should, everyone should be using SDK Man. You can also get all of our version builds from SDK Man. And if you want to build something new with GraalVM, if you want just to take it for a spin, you can get our demos and just build each of them and see the things that I was showing here today for yourself. Now, if you have any kind of questions, you can reach out to me, as I said, on any kinds of social media, and you can just also get demos from there. And I will be here for the rest of the day and also at the meet and greet. So if you have any questions, you can come to me here or during the breaks, and I will be happy to answer them. With that, thank you so much for coming.